Welcome, friends. Today we are going to be talking about the most important subject in your life. Your life, quite literally. We're going to be talking about healthcare. Well, actually, we're going to be destroying that barrier because we're not really talking about healthcare. We're talking about sick care in today's world. So I'll explain that one in a little bit. But we're also going to be talking about the future of health and wellness. We're going to be talking about the future of animal health, life sciences, and many, many more things. Basically, so while we're going to be having a look at the next 20 years, a lot of the things that I'm going to show you are actually here today. Many of them are actually in the labs, many are going through human trials, and so on and so forth. So my name is Matthew Griffin. I'm the CEO and founder of the 311 Institute, a global futures and deep futures think tank looking up to 50 years out. I cover over 600 emerging technologies, hundreds of different megatrends across every sector, every line of business, and every region of the world. And in this particular presentation, this is a re-recording of a presentation that I gave in Turkey to one of Europe's largest healthcare system integrators. Now, I've taken some of the bits out, that's it. However, I've left all of the good stuff in. Now, when we have a look at the future of life sciences, healthcare, and animal welfare, there's a huge amount to unpack. So we're going to focus a little bit on artificial intelligence, so there will be a bit of an AI bias, but that's not exclusive. That's it. We will be talking about lots of different things. So why don't I just shut up and get on with it? Now, when we have a look at the world around us, there's only one thing that's changing. I mean, this is kind of comedy for me. Yeah, there's only one thing that's changing. There's only one thing to get our heads around. However, unfortunately, as we all very well know, everything is changing. When you have a look around you, society itself is changing, technologies are changing, our environment is changing, our economies are changing, and obviously politics and geopolitics basically are having impacts across the world that have ripple effects basically for every single one of us, whether we like it or not. And all of these changes affect us directly and indirectly. Now, from a healthcare perspective, we believe that in 2028, we are going to achieve something called escape velocity. So in the pharmaceutical industries and the biotech industry around the world, they believe that 2028 is the pivotal year. So let's unpack. Now, what we mean by this is by the year 2028, we believe that we should have enough scientific revolutionary breakthroughs to add an extra year to your life for every year that you've lived. So this is really the age where we're getting into true life extension. And I'm going to be showing you the technologies, the breakthroughs, and everything else that we're doing today that makes this a reality. However, when we actually have a look at the future of healthcare, that's a misnomer. I don't really think that we have healthcare today. If you think about the healthcare industry today, what happens? You get sick, then you call the doctor, then you go to hospital. So really, we don't have healthcare. We have sick care. But with a lot of the medical advances that we see today, combined with a lot of some of the most sophisticated technologies that we have on the planet today, we do have the opportunity to move to a future where we actually have a genuine healthcare industry. We'll show you that in a bit. Now, when we have a look at things from a technology perspective, the fact of the matter is technology is just going absolutely nuts. As I said, I track over 600 emerging technologies. When we have a look at the biotech sector, for example, so this is my Starburst. You can download this from the 311institute.com website for free. There's a big poster that you can get, as well as a gigantic book, which goes through all of these individual technologies in great detail. There are 13 different categories on this particular Starburst. It goes up to 50 years out. But when we have a look at the biotech sector especially, which is the red sector down here, there's a huge amount going on. Okay, so let's see if I can get this right. Now, on the one hand, we've got the development of anti-aging drugs. So we've seen trials of anti-aging drugs on mice and rodents, as well as larger mammals, basically like rabbits. And we've been able to extend the lives of those mammals, which are sort of one under humans from a human trials perspective, by 30%. So there's actually quite a lot of interesting things going on in that space. When we have a look at things like artificial life forms, increasingly we're able to create artificial life forms with synthetic DNA, which fundamentally allows us to change human physiology, but also allows us to change the kind of drug treatments that we're actually creating. We have bioelectronic medicine. So in the United States, a little while ago, we saw the opioid pandemic. We've now started to get to the point where we can manipulate the body's electrical signals to eliminate chronic pain without the drugs. What else have we got? We've got biohybrid organs, basically. So this is where increasingly we're able to use, for example, biohybrid pancreases, which are a combination of human cells with technology. So a little bit like cyborg technology, for example, to help people with diabetes. Obviously, we've got CRISPR gene editing. We'll go into that in a little bit. In China, we've seen the rise of chromosome editing. So where CRISPR is the equivalent of using gene editing to rewrite, shall we say, life's paragraph or the code of life. Chromosome editing is the ability to edit the entire book. We've got electrogenetics. So electrogenetics is a very odd one. So electrogenetics is the use of sound waves to activate genes within your body that then produce, for example, different hormones and so on and so forth. That's it. So this is where, ironically, we recently played rock music to somebody who had been genetically re-engineered and managed to get their bodies to produce insulin. What else have we got? We've got injectable neuroprosthetics. Basically, that's a whole category in itself. That's quite literally the injection of really sort of nanobots, that kind of stuff. What else have we got? We've got memory editing, of course. That's it. So we've already been able to use optogenetics and sonogenetics to edit people's memories. Now, this is where we can actually literally get you to forget that you are addicted to heroin and so on and so forth. So that's kind of a crazy technology. We've got rapid gene sequencing. I'll touch on that later. Synthetic blood. So if you think about all the different blood banks around the world, one of the biggest problems they have is they continuously have to monitor all their blood stocks to make sure that blood hasn't actually gone off. So in the United Kingdom, we recently used stem cells to create synthetic blood, which is universal as well. Synthetic proteins. So when we have a look at synthetic proteins, we've been able to use artificial intelligence to create not only brand new exotic proteins, but also to simulate every existing protein on the planet. So that's just a little taster of some of the ways that we are using some rather exotic new technologies to change healthcare and change basically our own health and wellness prospects. But that's just scratching the surface. So as we go around there we go. There's obviously a lot of technologies. There's about 167 on there. Now, when we have a look at artificial intelligence specifically, we've obviously got the large language models. We've got large behavioral and large audio models coming through and large visual models coming through as well, which means that artificial intelligence is starting to become multisensory. However, when we really start having a look at the impact that artificial intelligence will have on healthcare, we're starting to enter the age of agentic artificial intelligence. So these agentic artificial intelligences have already managed to demonstrate that they can evolve by themselves, replicate themselves, and so on and so forth. So when we have a look at the use of agentic artificial intelligence combined with a variety of new, different, disparate healthcare-based data sets, which they can then ingest, analyze, and produce new treatments from, and so on and so forth, it's quite an interesting topic. We're at the very, very early stages of debating the impact of agentic artificial intelligence, basically within healthcare. We've also seen with companies like OpenAI, artificial intelligences that are now bootstrapping their own intelligence. So the way that this was done is if you think about ChatGPT was trained on huge amounts of data. It's a 2 trillion parameter artificial intelligence. We think GPT-5 basically will be much bigger. We think GPT-5 could end up with 50 trillion parameters, even though they won't necessarily tell us that. This is where artificial intelligence was trained on data sets, so it learned from existing data, but then started creating synthetic data sets, which let it learn new things from new data that it had generated to bootstrap its own intelligence. So what happens when artificial intelligence, which is already a healthcare multiplier, starts bootstrapping its own intelligence? Bearing in mind it can do this incredibly quickly, at speed and at scale. Uh, Now, one of the impacts of this, of course, basically is that artificial intelligence is able to create its own knowledge. So as humans, basically, we take different sets of information, combine them together in our squishy brains to produce knowledge, which we then use to produce wisdom, hopefully. Politicians aside. However, artificial intelligence takes information in a similar way to we do, combines it together, but analyzes it in a very, very different way. So it creates its own knowledge. So you have human-generated knowledge and artificial intelligence-generated knowledge. Now, we've seen this with Google DeepMind, if I want to give you some examples. So what happens to the healthcare space when we are not just applying human-based knowledge to try to solve some of the world's healthcare challenges, but we are now starting to apply really knowledge from what I increasingly call alien intelligences to solve some of the problems that the world faces? Now, where this becomes particularly interesting is in the development of what we call robo-scientists. So increasingly, we are seeing many organizations around the world trying to literally automate the process of scientific discovery itself. And while artificial intelligence is kind of at the 2-meter mark, if it's a 100-meter race, it's only going to get faster from here. So there are some really, really interesting things happening basically in the healthcare space when we have a look at what AI is actually already helping us achieve and what it might help us achieve in the future. And then, of course, OpenAI, Microsoft believe that by 2028, we might see the advent of artificial general intelligence. Now, we believe that AGI, based on what we've seen so far, could have an IQ of 1600. So ChatGPT actually has a verbal IQ that we've measured of 155. So when we look at scaling laws and everything else, we think that AGI could very well have a IQ of 1,600, which is, I mean, it's insane. That's about 10 times more than Albert Einstein and Elon Musk. In fact, putting it in human terms, it's 5 Elon Musks. We also think it will have 1 billion times more cross-domain knowledge than any human. Bearing in mind it can also then create its own knowledge. And ChatGPT's learning speed, according to Geoffrey Hinton, was 300 million times faster than any human brain. We think that the learning speed of artificial general intelligence, when we have a look at the increase in GPU performance, which NVIDIA says that by 2030, we should see a million-fold increase in GPU performance. We're seeing $100 billion artificial intelligence data centers being built by the likes of Microsoft and so on and so forth. We think that the learning speed of AGI might very well be around 3 trillion times faster than a human. So what happens when you apply this to helping people live longer, better lives? And I haven't even mentioned quantum computing yet, where recently Google released the Willow chip. And when we have a look at the Willow quantum computer chip, it managed to perform a calculation in 5 minutes that would have taken the world's largest supercomputers 10 septillion years to solve. And while it was a quantum computer optimized benchmark and test, that's insane. You can read more about that on the Fanatical, Futurist and 311institute.com blogs. Now, back to hitting escape velocity. So when we have a look at some of the universal changes across life sciences, healthcare and animal welfare spaces, there are a number of different breakthroughs that can be applied to all of them. And then in a little bit, we'll sort of flip a little bit more to human-based healthcare and so on and so forth. So when we have a look at the use of artificial intelligence, on the one hand, from an animal health perspective, we can monitor livestock populations. So this is where, ironically, we're using things like Internet of Things and trackers on cows to monitor the health of livestock in the wild or in the field, depending on how we want to phrase that. We can also track trends. So recently we've seen increasing number of pandemics, for example, the H5N1 bird flu and the swine flu pandemics. Now, if we're using artificial intelligence and provided we have access to the data, then it's increasingly easier for us to identify upcoming trends and future pandemics. Now, when we actually have a look at accelerating trials, again, by using digital twins, by using artificial intelligence to try to predict trial outcomes, we're accelerating and rapidly accelerating not only human trials and animal welfare trials, but also research and development. And I'm going to touch more on research and development in a little bit. Now, again, from an artificial intelligence perspective, and we've seen this being applied throughout Africa, increasingly. I will use the word increasingly a lot because this is the slowest that we move. So we kind of ramp from here. So increasingly, we are using smartphones and 3D printed microscopes combined with artificial intelligence and machine vision to identify every known pathogen in your blood. So this is the decentralization essentially of blood testing. If you think about, blood testing today, you have to go to a specific center, wait for your results, etc., etc. With this, we could arguably do it with a pinprick in the field. Now, we're also starting to see the application of artificial intelligence being applied in radiology. So this is where, for example, scans of people's lungs, basically we have artificial intelligence that can pick up lung tumors or cancerous tumors very, very early. So typically, basically with about a 97% level of accuracy. There are a lot of radiologists that I know that are worried about their jobs. However, what we've actually managed to see is when you combine the best radiologists with the best artificial intelligences, the results that they produce are 30% better than the results produced only by a human radiologist or only the world's best AIs. So when we talk about the rise of automation within the life sciences industry, there is a huge amount of benefit to be had by augmenting humans with some of these newer technologies. So we shouldn't just rush straight to automating radiology because we miss out on some of the benefits and productivity improvements. We also have the rise basically of predictive healthcare. So this is simply basically where we're using artificial intelligence, for example, combined with a variety of different scans. It could be PET scans, X-rays, CT scans, and so on and so forth. And this kind of technology is actually being trialed in Australia at the moment. What we're able to do is we're able to take all of these different individual scans, put them together. We can use artificial intelligence to diagnose the conditions that you have. And then, rather scarily and freakily, artificial intelligence can compare the problems that you have within your body to other people who've had those problems. And it can say, quite literally, and I kid you not, you have 3 years to live, based on what it's seen. So increasingly, as we use different technologies like Internet of Things, wearables, as well as different biometrics and biomarker information, we're able to predict when you're going to get ill. We're able to predict the outcome of particular problems that you have with your body much, much better than ever before. So for example, heart health, etc. So just on this one slide, there's a huge amount to unpack. We're also moving to healthcare on demand. Now, if we have a look at the different healthcare systems around the world, America's healthcare system broadly looks quite broken. It's the most expensive healthcare system on the planet by a factor of 2. We're seeing American healthcare outcomes actually falling for the first time ever compared to the rest of the world. And there are a lot of people that just think the American healthcare system, as it is a for-profit system, is just heading to a cliff. So when we have a look at the availability of healthcare on demand, it does vary by different geographies. So for example, in the UK, where we have free healthcare, we're rolling this out, and we've already rolled these kinds of technologies out. But in America, some of the technologies I'm going to talk about in a minute actually undermine some of the American giant healthcare revenue streams and profits. Yeah, so we kind of have a conflict of interest when it comes to healthcare outcomes versus profits. So let me explain. Now, today, basically, if you're feeling a little bit ill, traditionally you would phone up the doctor, you'd make a doctor's appointment or maybe a telehealth appointment, and you would talk to the doctor. Now, if you're in America, that appointment, you can cover it on insurance, obviously, but that could cost you $100, $200, $300, depending who you are, where you are, and your plans, etc., etc. However, when you have a look at the smartphone in your hand, I argue that increasingly it's not a smartphone, it's a tricorder. So when you think about the technologies that are packed into this science fiction-like device, increasingly we can use artificial intelligence to listen to your voice. And you know, when you get a little bit groggy, when you start feeling a little bit ill, you start speaking like Barry White, you know, whir. And people think you're getting ill because when you're talking to them, they say, you sound a little bit rough. Yeah, that is a vocal biomarker that we can use to predict that you are going to get sicker. Maybe you're getting the flu or COVID or whatever it happens to be. In addition to that, though, basically we can actually use the machine vision cameras in your phone to identify skin anomalies, so skin cancers, genetic abnormalities, even the onset of heart attacks and pancreatic cancer, because when you get pancreatic cancer, your eyes go slightly yellow. We can use the accelerometers and the gyroscopes in your phone to assess your posture. So we can actually assess from your phone whether or not you are depressed. Because if you're depressed, you might be sloping forward like this. You scroll slower. You pick your phone up more actually when you're depressed and upset. In addition to that, again, sort of going back to things like vocal biomarkers, we can actually tell whether or not you have PTSD, dementia, or the onset of Alzheimer's. So on the one hand, the smartphone in your hand is becoming increasingly a tricorder device, quite a sophisticated one that we can use to assess your overall mental and physical health. We can also use the camera to identify from your skin tone, your blood pressure, and so on and so forth. But when we're using these tricorder devices, all of the information that is being gathered, so the biometric and the biomarker information that's being gathered from your device, can be sent back to a healthcare professional or an artificial intelligence bot. Now, in the UK, we're using artificial intelligence bots to say, well, we've seen that you've got all these different symptoms. So just answer a couple of questions for us, and we will try to give you a diagnosis. So this is being trialled very, very heavily by the UK NHS in London, and so far it's been really successful. In addition to that, though, while you can speak to a genuine human doctor, you could also be speaking to a digital human with a neural network brain. So we are increasingly moving to the point in time where you have access to on-demand healthcare, but also on-demand diagnosis of any conditions that you might have, whether you know that you have those conditions or whether you don't know that you have those conditions. And all of this could simply be wrapped up in an app as a smartphone subscription for you. Done. Now, as I mentioned, when we have a look at healthcare today, the fact of the matter is you get ill. Then you go to see the doctor. But by using some of these different technologies that I've just discussed, organizations like University of Stanford have managed to use wearables, so in their case, a watch, to monitor your baseline health over a number of months. And as your skin temperature changes, as your galvanic responses change, and so on and so forth, as your pulse changes, etc., etc., using the latest artificial intelligences, we are able to tell when your body is deviating from its healthy baseline to something else. And then we're able to literally predict 2 weeks before the symptoms show that you are going to get ill. And while this is still fairly rudimentary, it's a really interesting concept because for the first time we move genuinely from a healthcare industry that is really a sick care industry to an industry that is actually genuinely a healthcare industry. So could we see the end of sick care using predictive health? Now, I mentioned earlier that artificial intelligence is rapidly accelerating the research and development of all sorts of different things. So let's give you some examples. So in Silico over in Australia recently used artificial intelligence to create 30,000 new kinds of drugs in 21 days. Normally that would have cost them billions of dollars and it would have taken them decades basically to do that. However, artificial intelligence just accelerated the process by multiples. Now, in addition to that, we've also got some rather odd and interesting artificial intelligences based on large language models basically coming through. There's one called Drug GPT. Now, Drug GPT is a very interesting AI because it lets you or I, and I'm literally talking about you or I, create fantastical new drug treatments. And I'll explain how it does it. So all you do, just like ChatGPT, you simply type, so you put in your text prompt and you say, I would like to cure XYZ disease. And the artificial intelligence, because it has access to a whole variety of different information sets and protein structures and everything else, says, right, well, I know what that disease is, so I've simulated that on an NVIDIA supercomputer. And because this is the simulation of the molecule that we want to kill, I'm now going to start running simulations on how to kill it. So the AI literally tries to figure out how you kill it. And it will run millions and millions of simulations over the space of minutes, hours, whatever it happens to be. And eventually it will say, this is the cure. This is the treatment. So we're using this in the American military at the moment. And again, when we have a look at the development, the use of artificial intelligence for drug discovery, but also drug creation, it's fascinating. Again, we are just scratching the surface of what's capable basically with these new technologies. But nevertheless, democratizing access to healthcare and drug discovery at a global scale, what would that actually do for the global, I say, healthcare industry? I'll keep using that even though we know it's a sick care industry. We've also seen vaccines, love them or hate them, depending on your political view. So we've also seen vaccines being developed in 7 minutes using artificial intelligence and supercomputers. That's it. So when we have a look at the COVID vaccine was developed in about 3 months, and then we ended up with 6 months of human trials, and eventually it came out into the market. If you step back about 5 years ago, to create a standard vaccine would have taken between 3 to 10 years, depending on what you were trying to create. So AI in drug discovery is now accelerating the process of R&D in drug discovery multiple times. Then once we've made our new drugs and drug treatments and so on and so forth, we want to test them and we want to create them. So more and more pharmaceutical organizations actually have fully autonomous robotic labs. Now, again, what we mean by this is they literally have robots from companies like ABB and KUKA that are trying to create all of these different things. So just as we have humans in the lab, you sort of see the traditional pipettes, kind of images going around. This is where robots will just keep putting different chemicals and compounds basically into different pipettes and different test tubes and running tests. That's it. So robot labs. So when we actually have a look at the future of healthcare from a system integrator perspective, we're seeing the integration of artificial intelligence across the space, quantum computing across the sector, but also actual general purpose robots as well. When we have a look at rapid gene sequencing, we've seen some amazing breakthroughs. If you step back 20 years ago to sequence the human genome, it would cost about $10 billion. About 3 months ago in America, we managed to sequence 10 human genomes, full human genomes, for under $100 for 5 hours. Now, why this is important is it means that for the very first time, it is commercially practical to take DNA samples from you. So this could be biopsies or whatever it happens to be, but we take DNA samples from you for whatever reason, and within 5 hours, we can have run a complete and thorough analysis, basically, of those samples. And when we actually start thinking about how we're going to use those, I'll come on to those in a little bit because the results are spectacular. However, staying on the topic of DNA, we are quite literally not only getting better at understanding life's code, the language of life, DNA, but we are increasingly adding to it. So we have now seen numerous cases in the labs where we have 8 base pair DNA, 11 base pair DNA. So as we understand the code of life better and better, as our ability to manipulate it and add to it only improves over time, all of a sudden we can create things like hybrid human immune systems, where we genetically re-engineer human T cells to attack cancers with 100% effectiveness, and so on and so forth. So when we have a look at synthetic biology as an upticking trend, combined with gene sequencing and all these other things that I've mentioned, this slide here, you could argue, is more impactful to humans than artificial intelligence. Bearing in mind, we can also, because we've done it, create DNA-based neural networks and artificial intelligences which outperform even the best AIs on the planet at the moment in the labs. So stepping back basically to gene sequencing. Now, when you get cancer, so a third of people on the planet will get some form of cancer. Every single cancer is unique. However, when you go to the hospital, you will get given immunosuppressant drugs and chemotherapy. And those therapies, while they vary slightly, the treatments, the cancer treatments that you will get as an individual will be relatively similar to the treatments that everyone else has had. However, in both China and the United States, we used gene sequencing combined with gene therapies to kill 100% of grade 4 tumors. This is how we did it. So we took biopsies from the tumors. We used gene sequencing to identify the unique genetic sequences within each of the patient's cancers and tumors, then created hybrid T cells. So genetically manipulated, genetically engineered T cells. These T cells were turned into quite literal human cancer hunter killers. So the T cells are now looking for a specific genetic sequence, which is unique to the cancer that we've just taken the biopsy from. They go and hunt it down, they kill it dead. So when we have a look at the use of gene sequencing and the rise of personalized medicine, combined with human ingenuity, we are truly on the cusp of some staggering breakthroughs. And at the moment, these kinds of treatments are about $2.5 million each, but eventually they start coming down. The regulators have to obviously assess them, and so on and so forth. Now, when we have a look at human health specifically, there's a huge amount of improvements that we're making again. So you can tell basically from this presentation what's actually happening. The breakthroughs that we're seeing in the life sciences sector is phenomenal. And again, we're kind of scratching the surface still. So the World Health Organization has said that the antibiotic resistance that we see today is quite frankly a pandemic. However, we have now seen artificial intelligence develop 3 completely new classes of antibiotics. One of these was produced at MIT, and then the others basically were produced elsewhere around the world. Now, in some cases, we are actually using gene therapy to create what we call genetic chainsaws. So some of the antibiotics will actually go in, identify their target phage or their target pathogen, and quite literally go in through the cell membrane and, just like a chainsaw, take a chainsaw to the cell nuclei. In addition to that, basically, we're seeing the rise of things like phage therapy as well. So this is where we're using genetically modified viruses basically to go and kill pathogens for us. We are seeing a huge increase in the number of antibiotic medicines that are starting to come through, thanks to artificial intelligence and, again, human ingenuity. When we have a look at inherited diseases, recently in the United States and the United Kingdom, there was a chap called Patient Zero, not from a pandemic perspective, but it was called it was called Patient Zero. And what we did is he had Hunter's syndrome. Now, Hunter's syndrome is a genetically inherited condition that has two pieces of news associated with it. So the first piece of news is you've got Hunter's syndrome, you're going to die in 20 years. The second piece of news is actually the bad news. You're going to die painfully from it. So patient Zero was put into a bed in London and he was given an intravenous drip of a new gene therapy that did in vivo gene editing. So this gene therapy went into his body, found the bad genes, clipped them out, and clipped in new good genes. He no longer has the inherited genetic condition he was born with. And you can apply that kind of technology and that kind of treatment to over 6,000 currently incurable diseases. And even when we have a look at things like cystic fibrosis, increasingly we are using inhalable mRNA treatments that are able to go into your lungs and start editing mRNA sequences to reduce the impact of things like cystic fibrosis. But these are in the labs. So I'll stress that these are in the labs. So again, when we actually have a look at not just how we're using artificial intelligence, how we're using gene therapy, gene editing, and so on and so forth, when we actually have a look at the delivery mechanisms, whether it's actually a vaccine via a needle patch, whether it's vaccines delivered via chewing gum or actually put into foods, as we've actually seen with chickens, and we've actually been growing vaccines in fruit of all things. Increasingly, we also have the ability to create new delivery systems that are inhalable. And actually, while we're on that topic, when we talk about vaccines, we've also developed, again in the labs, the concept of contagious vaccines. So just as you start getting, for example, COVID, I mean, I know basically it's, yeah, let's face it, let's not touch that with a political barge pole. But when you think about COVID, one of the biggest problems that we had trying to solve it and cure it was the distribution of vaccines. What would happen if I can simply give one person a contagious vaccine and then everyone they come into contact with gets the vaccine rather than the disease? Conspiracy theorists love me because, frankly, I go way beyond anything that they can. So yeah. But this is genuinely what technology is actually letting us do today. We also have the end of paralysis. Now, today, when we have a look at this, the general status quo is you're involved in a car accident, you break your vertebra, and then you're in a wheelchair for life. The insurance company pays out $1.5 million typically, and your life is changed. However, using stem cell therapies, using bioelectronic medicine, using nerve regenerative medicine, where we can actually regenerate nerves basically within your spine and so on and so forth, we now have about 100 cases of where we have completely reversed some of the even worst paralysis cases. So, for example, there was a French journalist who'd been stabbed in the back 64 times. I mean, he was completely paralyzed, and actually using some of these new treatments, he's now walking again. So paralysis is no longer for life. And when we have a look at the next pandemic, on the one hand, we can use artificial intelligence to identify patterns in big data to identify that there are outbreaks of particular diseases in these particular regions and that trend is ticking up. And then we can use simulation modeling, as we see with the CDC, to say, well, if we've got these disease outbreaks here, if someone gets on a plane to New York, basically then suddenly we have an outbreak there. But when we talk about the end of the next pandemic, what we literally mean is we've been using artificial intelligence on COVID-19 to try to understand how it could mutate. So when you have a think about most pathogens, all pathogens contain 4 base pair DNA, at the moment anyway. There is only a number of ways that they can actually mutate. So with Harvard, what we managed to do is, using artificial intelligence, we managed to predict all of the different ways that COVID-19 could mutate. And the artificial intelligence, for example, said, right, there are 1,000 ways that it can mutate. And then we run analyses and it says, well, the top 5 have got a very high R count, so they're highly contagious and they're highly lethal. Okay, so these are maybe the 5 mutations that we are the most worried about. The other ones will just peter off, for example. Now that we understand what the future mutations could look like, we can now use artificial intelligence to simulate the virus, and we can create the vaccine before the virus ever arrives on the planet. Now, again, I mean, you can imagine that from a conspiracy theorist perspective, where you end up with a new pandemic, basically, and then people say, "Oh my God, how is it that people already had the vaccine available?" Filthy rich people, etc., etc. Actually, it's the ingenious use of technology to predict how different pathogens are going to mutate, so that we can actually get ahead of them. And I actually call this predictive medicine. Now, it doesn't really have a name. That's the name I'm giving to it. No one else really is seeing this at the moment, so except for you. So what happens when we can not only predict that you're going to get ill, but we can also predict the illnesses that you might get ill with? Science fiction is now science fact. When we have a look at the end of diabetes, so diabetes, basically we've got a variety of different monitoring systems and everything else. Basically we've got biohybrid organs, basically which actually kind of sit outside the body, as I mentioned earlier. But recently we've used pluripotent stem cells to regenerate the insulin cells basically within the pancreas. So when we have a look at type 2 and type 3 diabetes, increasingly we could use stem cell therapies to completely eliminate your diabetes. And then, of course, we have the end of waiting. Now, when we have a look at most people, if you have a heart attack, for example, if your liver or kidneys fail, inevitably what has to happen today is someone has to die, a compatible donor has to die, and then you end up with their organs. Now, we're tackling the organ, should we say donation, but the organ transplant problem from a variety of different angles. Now, firstly, we've created universal organs. So by putting organs basically into a kind of cryostasis, we've been able to create universal livers. So that means you no longer need to wait for a person with a compatible liver to you to die. You can kind of, unfortunately, still wait for somebody who has a liver to die, and then we can turn that into a universal organ using different chemical compounds and everything else. Okay, so that reduces the waiting list. But the fact of the matter is, wouldn't it just be better if you didn't actually have to wait for someone else to die to get their organs? So this is where increasingly we're using 3D printing and 4D printing to print new human tissues and organs. So this is muscle, bone, this is liver, kidneys. We've even managed to 3D print human hearts, very small human hearts in Israel that actually beat. Now, when we have a look at the difference between 3D printed organs and 4D printed organs, a 4D printed organ can grow with a child. So if you 3D print an organ and it's this big, then it stays that big forever. However, if you 4D print an organ this big, then using scaffolding technologies and all kinds of different things, it grows with, for example, the child. So increasingly, when we actually have a look at our ability to 3D print human tissues and organs, on the one hand, we can predict that you're going to have a heart attack using wearables and artificial intelligence and so on and so forth. We can send you the ambulance before you have the heart attack. But if a hospital has your pluripotent stem cells on file, then they can 3D print you a new heart, complete with electronics if you want it, so that when you get to hospital, if your heart is completely irrecoverable for whatever reason, they can just put it straight into you. And because it's your own heart, because it's made from your own pluripotent stem cells, it is basically you, there is no risk of immuno rejection. So again, science fiction rapidly becoming science fact. Then when we have a look at needless suffering, so again, who would have ever thought that we could decentralize and democratize surgery? Now, if you have, I'll pick on heart attacks again, but if you need brain surgery or heart surgery, the fact of the matter is that today you have to leave your house, go to the hospital, lie on the surgical bed, and the surgeons basically will operate on you in theatre. However, using robotic surgeons, so these are robots like the Da Vinci robot, but we actually see this with dentistry as well. We see the rise of semi and fully autonomous robotic systems. Increasingly, what we're able to do is we're able to use these new robotic systems, couple them with a 5G network, and the surgeon that would normally be standing over you, operating on you, can now be anywhere on the planet. So, for example, you could be in London and you could have a heart surgeon based in Shanghai that is doing your heart surgery. Now, every year, over 148 million people, according to the World Health Organization, live with, should we say, disabilities and healthcare related problems that surgery could fix. However, they don't have access to surgeons or surgeries, which means that we have almost 150 million people on the planet living day in, day out in a variety of different pain. What would happen if you just went to a mobile surgery, for example, in Addis Ababa, and you have a couple of people there just to sort of help you, obviously, and everything else, but the surgeon themselves are based in, say, St. Guy's and St. Tommy's Hospital in London. So what happens to global health outcomes when you are able to decentralize surgery? And it's not just heart surgery. We've done it in India with brain surgery as well. When we have a look at drugs today, one of the greatest problems that we see, for example, with chemotherapy drugs as well as other kinds of drugs, is if you get ill or when you get ill, we flood your body with drugs. So, the tablets, you'll take the tablets basically, and those tablets basically will dissolve throughout your body. Whatever is in those tablets basically will end up being rooted throughout your body via the bloodstream. Which means that those tablets and those treatments and those pills, basically, they actually get diluted. Now, when we have a look at nanotech, because we couldn't really talk about the future of sick care without having a look at nanotech, increasingly we are using nanotech. So these are nano machines and nanobots that are able to deliver drugs precisely to where they are needed. So if this part of your body needs the treatment, because, I don't know, maybe you've got a tumor or maybe it hurts or, whatever the heck would go on here. Rather than flooding my body with drugs, I could just send the drugs to here. And then those drugs treat whatever this is. So when we have a look at the rise of nanomedicine and nano-based healthcare, we've seen some staggering breakthroughs in both nanoparticles, nanomachines, nanobots, nano lots of things. However, regulators will freak out. We've even seen the first examples of nanobots in China that are able to swarm together to do very basic in vivo surgery, although the in vivo surgery they did was pretty much in a test tube. So when we have a look at machines in the body, we've also now developed 3D printing robots which are able to go into your body and say, for example, you've got a tear in your lower intestine. Rather than having to actually open you up, we can send in a 3D printing robot to 3D print tissue within your body to fix the tear within your body, and then obviously it comes out. So when we have a look at the convergence of nanotechnology, 3D printing, and all kinds of other things. It's just staggering, absolutely staggering. Virtual reality, so kind of looking at VR a little bit here as we start getting towards the end of this particular presentation. When we have a look at virtual reality, increasingly we're using virtual reality to do surgery. So this is where, for example, again in London, we're using virtual reality to zoom through patient tumors and cancers and so on and so forth. So a surgeon can literally zoom through your tumor to identify all of the different things that he or she wants to do. So kind of preparing for surgery in a different way. We're also using virtual reality in rehabilitation therapy as well, which has actually been really successful because by putting people into virtual reality, they kind of end up feeling different, so different emotions and everything else, but can also be exposed to different kind of environments and so on and so forth. Virtual reality training, so rather than actually using a genuine human cadaver, basically for doctors to train on, we can do that in virtual reality. Pain management. So interestingly enough, people with chronic pain, when they've been put into virtual reality worlds like forests and so on and so forth, they've actually been able to manage their chronic pain better. And then obviously rehab we talked about. Now, from a healthcare perspective, when we have a look at the topic of security, because you're a biotech, you're a pharmaceutical organization, whatever you happen to be, the fact of the matter is, all of these amazing things that I've talked about, spies are after them. Hackers want your IP and information basically because they want to sell it. They want their own country basically to be able to benefit from all these different things, and they just can't wait. We saw that basically during the pandemic. Now, when we have a look at the threats that are already here to, for example, biotech companies, and in the UK, basically, we've got the Cambridge Biotech Triangle and hubs and so on and so forth. We've already seen the development of fully autonomous agentic cyber weapons. Now, when we have a look at agentic cyber weapons, these are essentially agentic artificial intelligences trained like traditional large language models that were able to chain together zero-day exploits to break through military-grade systems in 2 minutes. So when we talk about the arrival of fully autonomous cyber weapons, they're already here. And if you want more on this, go and check out some of my cyber security videos, basically with companies like Fortinet and everything else. And this is sort of where we talk about how we resolve this. But that's a little bit off topic for this conversation. We've also got Q Day approaching. So by 2028, we should see the arrival of sufficiently powerful and accurate enough quantum computers that are able to break 256 AES bit encryption within 8 minutes and 4096 bit encryption within 12 hours. So if you're a biotech organization and you have lots and lots of secrets and you've encrypted those secrets, if I, as an adversary, can actually steal those secrets from you, then sooner, really, rather than later, I'm going to be able to use a quantum computer to reveal all those secrets, and now I have your IP. When we have a look at pandemics hitting healthcare, the criminal or serious organized crime industry is a $7 trillion industry. $1.2 trillion of that revenue is directly comes from crypto heists and ransomware. So when we have a look at the healthcare industry, unfortunately, the biggest pandemic that they face, we could argue, is the rise of ransomware. Because it used to be the case that state-sponsored actors and criminal organizations and bedroom hacktivists would not target healthcare institutions because it was unethical, immoral. That's no longer the case. In America, for example, we've seen huge numbers of healthcare organizations, including the insurance organizations and bill-paying organizations, literally being crippled, not just being taken out, but literally being crippled by ransomware. This is the rise of a new pandemic. Now, what we can do is we can use artificial intelligence to identify ransomware in data streams. And we can also use artificial intelligence to identify, should we say, exceptional behavior on your critical infrastructure that might indicate that all your files are starting to be encrypted. and then we can make an intervention and so on and so forth. So we do have some solutions to ransomware, but let's face it, it's a new pandemic. So increasingly, kind of the point of this section is whether you are a giant pharmaceutical, basically like GSK or Merck or Roche, etc., or whether you're a small biotech company, increasingly you are going to have to pay much more attention to your cybersecurity posture, which is again what I talked about to this system integrator in Turkey, because from a system integrator perspective, not only is this an opportunity, but it's a must-have. Then we also have DNA malware. So a couple of years ago, we managed to encode malware into physical DNA. Now, when that DNA was put into a gene sequencer at a police forensics lab, the DNA was compiled into binary, the binary executed and wiped the police forensics servers. So this is where we start crossing over from traditional malware and so on and so forth, which are ones and zeros, to literally physical malware. We haven't actually figured out how a computer virus can give you as a human an actual virus yet, but when we have a look at the use of artificial intelligence to create new human genomes and new synthetic genomes, we've already done that. We are already there. So this slide here is, well, it could portend to something much, much nastier. And then we've also got the development by biotech firms of what we call accidental synthetic bioweapons. Now, you can imagine a lab basically saying, oh, I didn't know that I accidentally created a bioweapon. So what we've actually seen is we've seen some serious organized crime groups that have been using malware to change the synthetic DNA sequences within genomes or genes that different biotech labs have been creating for whatever reason. So a biotech lab will create, for example, a genome or a gene therapy because they want to. As I say, we've actually seen some of these organizations being targeted by serious organized crime groups. And what actually happens here is the malware will change the DNA sequence basically within, say, for example, a gene therapy. Now, that gene therapy is typically made up from synthetic DNA from companies like Twist Bioscience in the United States. So the biotech company sends Twist Bioscience their new gene therapy, their new genome. Twist Bioscience will then compile it and create it for you and then send it back to you. However, the malware has encoded bioweapons into that DNA. So when we have a look at the UK national security apparatus, there's an organisation called IARPA, which is the intelligence equivalent of DARPA, which is the bleeding edge US military research organisation. And what we're doing with IARPA is increasingly we're using machine learning and artificial intelligence to identify bad, nefarious, malicious things in the synthetic DNA that we're actually creating so that we can catch bioweapons before they are actually synthesized in the lab and then sent back to the biotech companies who then say, by the way, here's your new treatment. Hope it doesn't kill you. So when we have a look at the rise of accidental synthetic bioweapons, as crazy as that actually might sound, this is a new threat vector. And then when we have a look at trials and regulations, on the one hand, if we take COVID as the example, it took 3 months basically to create the vaccine. We then had to test it on tens of thousands of humans, which took about 6 months. If we want to use artificial intelligence to develop new drugs and treatments and everything else for perfectly reasonable, benign purposes, then it would also be very handy to speed up the human trial element. So what we've been doing here is we've been turning humans into quite literal digital twins. So we turn you into a cell-based copy of yourself. So we turn you into a digital twin of yourself. And with the new treatment, in a computer simulation, we then test the new drug treatment on your digital twin. And if it kills your digital twin, then it's just killed a digital twin. And we reboot the digital twin and we keep running. But now we do this at huge scale. So what we're able to do is we create a new drug treatment. We run the drug treatment on a simulation of a huge number of digital people. And when it doesn't kill them, when we get the results that we actually want, then we can start saying, right, now let's actually trial this on real humans. So what we're doing is, on the one hand, we're taking some of the risk out of human trials, but we're also taking a huge amount of time and cost out of human trials as well. So the net result being that we create a new drug treatment for a particular disease that we care about curing, and we can now get that drug into the market much, much faster if the regulators allow it. And when we have a look at the regulators, it used to be the case that organizations like the FDA in the United States would take years and years to ratify and approve new drugs. However, in the US military, what we're actually seeing is we're seeing the US military starting to use artificial intelligence for drug discovery and to create new drugs and treatments, as we've discussed. However, there is now a DARPA program called the EQUIP program. And it's interesting because what it does is we have AI creating a drug. So let's take the vaccine example. So AI has created a new vaccine in 7 minutes. Within 10 minutes, we've tried those vaccines on 1 million digital humans, and they're all fine. Now, in times of war, conflict, pandemics, or whatever it happens to be, if we don't want to go to human trials, what the FDA is now able to do, using preset criteria, is they can then run tests on that particular drug that we've just created, and they say, right, it's met all these different criteria, we're now going to approve it. So the EQUIP program is not just about trying to accelerate the drug approval process. It is about trying to create it so that it is real time. Real time drug approval? That's staggering. Now imagine that we sort of apply this process across other compliance and regulations, around the world in different industries and everything else, like financial services industry. Yeah, again, even just this slide is revolutionary. So that's it. Yeah, so now as we kind of close out, as individuals and as businesses and leaders, what I would encourage you to do is unlearn everything that you think you know. Because increasingly, the world that we are already creating works by fundamentally new rules. Experiment. So as we see all these new technologies starting to appear, go and experiment with them. Find out what's good about them, what's bad about them, etc., etc. Explore. So if you're in the healthcare space, don't just explore what you're doing and what your competitors are doing in your space, but go and explore. So go and explore other healthcare organizations and research and development labs basically around the world, because different countries innovate in different ways and do different things for different reasons. However, also go and have a look at what's happening basically in other industries as well, because a lot of the disruptions that are actually coming, with some of these disruptions, for example, they're actually coming from organizations like Google. So Google, a search company, is now increasingly also becoming a healthcare company. So go and explore, get out of your swim lane, and then expand your thinking. Because increasingly, if you are not open-minded, then you might look at this presentation and think, this is a load of hoo-ha. But all of the things that I've shown you exist today, and you can go and see them and touch them and prod them and poke them to your heart's content. But in addition to that, from a cultural perspective, as an organization, if you see some of these things as a threat, so let's take, for example, the rise of on-demand telehealth, telepsychiatry, and so on and so forth, as well as even teledentistry in the United States. If you see these things as a threat to your business model, anything that disrupts your business is also a business opportunity. So we stand on the cusp today of being able to fundamentally revolutionize human health and wellness for the betterment of everybody on the planet, young and old. And that is not something that should be seen as a threat. It should be seen as the ultimate opportunity for all of us. So thank you very much for listening, and I hope you enjoyed the presentation. If you want to know more, then you can download all of my different codexes and books basically from this link. So I've got trends codexes, I've got emerging technology codexes, I've got posters, I've got a blog basically. So if you go and have a look at the healthcare section of the blog, there are thousands of health related articles basically on how we're pushing the boundaries of all these different areas. And if you've got any comments, put them in the comment section below. And I hope you enjoyed this, and I wish you a long and fruitful life. And I genuinely look forward to the rise of the healthcare industry. Goodbye.